Hi, I'm Jakub Kukielka, and today I'll be demonstrating the SWAMS project. SWAMS stands for Smart Wireless Aquarium Monitoring System, as it provides data wirelessly and has built-in logic functions, which allow it to make choices based on the current state of the aquarium without user input. SWAMS features a real-time clock, an LED driver, a pH sensor, and a temperature sensor. SWAMS provides an interface for each device to monitor or change the environment of an aquarium. Let's take a look at future situations where SWAMS may help stabilize an aquarium. In general, two main devices are connected to help an aquarium function. This includes a filter and a heater. The filter cleans the water of any impurities, and the heater increases the aquarium's temperature to make it more habitable. I'll be demonstrating the heater and the filter of two lamps, which both run on mains power to 140 volt AC. Now let's see how the heater is regulated. In the software, we set maximum, minimum, regulated temperatures, and the threshold which determines when the heater will be switched on or off. These are two cups which both contain hot and cold water. If we were to increase the temperature, we shall see that the heater will switch off. Let's demonstrate that. And now a buzzer alarms to tell the user that the temperature has been increased beyond the level. Now if we decrease the temperature, we will see the heater switch back on. And now an alarm buzzes to alert the user that the temperature has gone too low for the system to handle. Each part of the alert system has its own unique code, which a user can work out what went wrong with their aquarium. Now what happens if the water level is increased? To simulate this happening, I'll be lowering the water level sensor in myself, and when the sensor will touch water, we shall see that the filter will turn off, and the user will be alerted using the buzzer. Now we take it out of the water, it's back to normal, and the filter turns on again. A real-time clock is an important part of the SWAMS project, as it determines when the lighting system will turn on or off. Currently the lighting system is programmed to turn on when the time can be divided by 2, else the LEDs will turn off. So, in the next minute, we shall see these LEDs turn on. Now the LED strip has fully turned on after a minute. So this demonstrates the powerful capability of the real-time clock being able to interface with the LED strip. And in future implementations, you'll be able to set the LED strip to light a specific hour every single day. Here we have 4 liquids: soapy water, water, vinegar, and bicarbonate of soda and water. Vinegar is the most acidic with a pH of 2. Soapy water is on the acidic side, about 6, and bicarbonate of soda is about pH 9. So let's check the monitoring function of the SWAMS client and dip the pH sensor into each liquid and see what result we get. To enable monitoring, simply press the Start Monitoring button. Right there. Let's first place into the vinegar, which get a very low pH, and we can see dip down to about 1.76 pH. Now let's try putting it into the bicarbonate of soda. You can see the pH value increasing. It's gradually increasing upwards due to the capacitive nature of the rectifier stage. there's a bit of a delay between changing the pH levels. You can see it go up. We'll go to about pH of 9. There we go, so we have a pH of 8.96, which is very close to 9. Now we have a stable pH level. Finally, let's dip it into the soapy water, which should be about pH 6. And as we can see, the pH value is 5.62, and it's fairly accurate. It's dropped quite quickly. So you can see how powerful the graphing functions are, as you can really see how the pH changes over time. As we can see, we get approximately the results we expect. However, due to the method used to calibrate the device and the fact that I don't have access to any liquids of very specific pH, or potentially more accurate devices to measure pH with, I'm unable to calibrate this device to be fully accurate at this time. But all calibration is performed on a client software, which converts the raw data sent from the main board. This will make it easy to calibrate in the future without having to modify the hardware or firmware in any way. The main target market for SWAMS is aquarium hobbyists of any skill level and age. Novices will find the data monitoring alert system helpful in maintaining a healthy aquarium, as they'll be able to notice quickly if anything was to occur which would damage the aquarium's habitat. In reality, however, if this was a complete product, it would be much easier to set up if I had access to a complete printed circuit board with all the connections already made. It would also include a case with all the measurement tools built in to make setting up even easier. However, as it is, SWAMS offers powerful hardware and software which have the potential to make a big impact regarding the health of aquariums, and offer people real data about their aquariums just from their smartphone. For more information, visit the webpage at argrac.me/swams or contact me via email. Thank you for watching.